Good morning. Myself Prabhakaran J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is circular convolution. And from the unit 1, that is discrete Fourier transform. From the subject is digital signal processing. Let us discuss. Yeah, convolution. Convolution in the sense convolve the two sequence, that means multiply the two sequence. Why we are using convolution? To find the output of a system with input and impulse response of the system. Linear convolution is used. Okay, circular convolution can be applied for periodic signal. What is mean by periodic signal? Periodic signal in the sense repeat the its value at a particular period, which means which is periodic signal. Period signal, circular convolution can be applied for periodic signal and to obtain linear convolution through circular padding of zeros are done. Okay, and circular convolution formula, here you can see the formula for convolution. What is the formula? Last video we have discussed which means y of n, which is the output of the system. Y of n equal to x of n convolve with h of n. X of which is equal to summation k equal to n minus 1 x of k into h of n minus k, and which means third signal, that is convolved signal, x3 of n equal to x1 of m convolved with x2 of n minus m, here where m is nothing but the length of the h of n, and n is nothing but the length of the input sequence. Okay, this is the circular convolution formula. Here you can see y of n equal to x of n, circular convolution of h of n. This is the circular convolution formula. Okay, there are two here. Circular convolution has two methods. That is, first one is concentric circle method and another one is matrix multiplication method. Let me see concentric circle method. Here they are given two sequence, that is x1 of n and x2 of n. The circular convolution of this sequence, which means x3 of n, that is convolved signal, x3 of n equal to x1 of n and x2 of n, which means circular convolution of x2 of n. x3 of n equal to x1 of n, circular convolution of x2 of n. You can see the formula. Y of n equal to x of n, circular convolution of h of n. Y of n is nothing but the third signal, that means x3 of n, which is equal to the first signal x1 of n is equal to x of n, x2 of n, which is equal to h of n. Okay, and steps. Let me see the steps involved in concentric circle method. First, you have to graph capital N sample of x of n as equally spaced points around an outer circle in counterclockwise direction. Counterclockwise in the sense anti-clockwise direction. And second step, this is the first step, counterclockwise. The outer circle, draw the outer circle and all samples points in all samples map in anti-clockwise direction with equally spaced. This is the first step of concentric circle method. And a second step is start at the same point as x1 of n. Start at the same point of x1 of n. Graph capital N samples of x2 of n as equally spaced points around an inner circle in clockwise direction. Okay, in clockwise direction. And third step, multiply corresponding samples on the two circle and sum the product to produce output. Rotate the fourth step, rotate the inner circle one sample at a time in counterclockwise direction and go to step 3, obtain to obtain the next value, next output value. Okay, this is the steps, these all are the steps involved circular convolution. Repeat these 4 steps until the inner circle first sample line up with the first sample of the exterior circle once again. Here you can see the examples of first sequence mapped in outer circle with anti-clockwise direction. Then second sequence mapped with inner circle with clockwise direction, and rotate and multiply the samples and add the values. Okay, multiply these samples on the two circle and sum the product to produce output. And another step is rotate inner circle at one point, then multiply and add the values. Do this process until we will get the starting point. Okay, these all are the examples of circular convolution. Okay, next one is matrix multiplication method. In this method, the circular convolution of two sequence that is x1 of n and x2 of n, which x2 of n is nothing but the h of n, h of x1 of n is nothing but the x of n obtained by representing the sequence in matrix form. Okay, here you can see the matrix first sequence and column matrix of second the sequence x2 of n is repeated via circular shift of samples and represent the capital N cross n matrix. Form the sequence x2 of n is represented as column matrix. The multiplication of these two matrices gives the sequence x3 of n. This is the matrix multiplication. This is simple. And x1 of n, x2 of n, x1 of n, the x1 of n mapped in the circle in anti-clockwise direction. Then x2 of n is clockwise direction. And rotate anti-clockwise direction one point at a time and multiply the sequence and add the values. Finally, we will get the y of n equal to 14, 16, 14, 16. This is the output of the system using circular convolution. And these all are the difference between circular and linear convolution. Circular convolution, only the periodic, only apply the periodic signal. And linear convolution, two signal returns n minus 1 elements where n is capital N is sum of element in both sequence. Circular convolution returns same the number of elements that of two signals. This is the assessment of this lecture. Note it down and give the answer of these questions through the comment. If you have any doubt, you can ask me through the comment. Okay, thank you. We will meet in next video.